Okay, so today we're going to be covering aldehydes, ketones, carboxylic acids, esters, and amides. All of these 5 different categories of organic molecules share a carbon-oxygen double bond somewhere in their structure. This is called a carbonyl. It's not really a functional group in and of itself because the function that it has, the chemical reactivity that it has, is strongly dependent on what else is going on around this carbon. But it is a feature that is common to all of the different categories of organic molecule that we're going to look at today. So the first one is an aldehyde. So an aldehyde is going to have that carbonyl on a terminal carbon. So this is the beginning or the end of a carbon chain, and it's got the carbonyl on there. So an aldehyde is named with an Al on the end. So you can have methanal, ethanal, and propanal, and that just tells you the number of carbons in the chain, and then the Al ending tells you that it's an aldehyde. Also, sometimes it ends in not just Al, but the full name of aldehyde, so you've probably heard of formaldehyde. Formaldehyde is a less common name. It's methanal is the name for formaldehyde that we're going to teach you. So formaldehyde, in other words, has just the one carbon with the carbonyl and 3 hydrogens around it. So formaldehyde is a common name for what we will call methanal. Ketones. Ketones have the carbonyl just somewhere in the middle of the branch of the chain, and so this carbon is not a terminal carbon. It's somewhere in the middle of a chain, which means there's no ketone for any ethane or methane based molecules. That you need to have 3 carbons or more in order to put the carbonyl in the middle of the chain. A good example is acetone. So oops. So that is acetone. It's the simplest ketone. Acetone is its common name. The actual convention that we'll be using does end in the name ONE, but we would call this propanone because there are 3 carbons here. So propanone. Propanone. Okay, so aldehydes and ketones can be generated by the oxidation of an alcohol. Actually, what I'll do is I'll write over here. So if I have a carbon that is a primary alcohol or an OH group on a terminal carbon, and I oxidize it, and that means I react it with something like dichromate or permanganate or any other common oxidizing agent, then it will turn into an aldehyde. It will lose 2 hydrogens, and it will change this single bond to a double bond to make it into an aldehyde. If I have a secondary alcohol, so this is an alcohol that is on a carbon in the middle of a chain that has 1 hydrogen here, and I oxidize a secondary alcohol, then it will form a ketone. And tertiary alcohols, one that has the OH on a carbon that is bonded to 3 other carbons, well, these tertiary alcohols cannot be oxidized. So primary alcohols oxidize to an aldehyde, secondary alcohols oxidize to a ketone, tertiary alcohols cannot be oxidized. Oh, whoops, I forgot I have a figure. Let me see if I can pull it up really quickly. Was it figure 2119? I apologize. I usually have these ready to go, but yeah. So figure 2119 basically just shows what I was just talking about, that primary alcohols that are on the end of an R group will oxidize to an aldehyde, that secondary alcohols in the middle will oxidize to a ketone, and that tertiary alcohols will not oxidize at all. Okay, so next we have carboxylic acids. Just one L. So carboxylic acids are going to have a carbon double bonded to an oxygen and a hydrogen. So it looks sort of like a carbonyl together with an alcohol. Maybe it's like an aldehyde and an alcohol. The reality is that carboxylic acids have very different chemical properties from an aldehyde or an alcohol, and so we just call it its own functional group. In carboxylic acid, you can imagine that there's going to be an acidic hydrogen somewhere in this moiety, and it is right there. That hydrogen is readily donated. Things like acetic acid or formic acid are examples of carboxylic acids. A carboxylic acid is generated by further oxidizing an aldehyde. So if you have an aldehyde and you oxidize it further, then it will form a carboxylic acid. A ketone, like a tertiary alcohol, cannot be oxidized further, but an aldehyde can, and it will form a carboxylic acid. A carboxylic acid is going to end with the oic acid ending. So if I have CH3COOH, we're used to calling that acetic acid. That's a common name. If we wanted to name it according to our convention here, then we would see how many carbons there are. 1, 2 carbons. And so it has the parent name of ethane, but we will change the ending to say ethanoic acid. And that's certainly not a common thing for a chemist to say, because acetic acid is the more popular name, but ethanoic acid is technically what we should be calling CH3COOH if we're going to follow the convention for naming carboxylic acid. Formic acid would be methanoic acid. You can have propanoic acid, butanoic acid. It all depends on how many carbons there are before that carboxylic acid group. Okay, am I in the right order? Oh, I am. Okay, sorry. So next are esters, and esters have an RCOOR prime is how it's written. What it'll look like is a carboxylic acid, but instead of having a hydrogen here, then you'll have a carbon, and just and that will go on as a carbon chain of however long it's supposed to be. So esters are actually formed by a carboxylic acid, so you would have RCOOH plus an alcohol, so we'll do HOR prime, and these two hydrogens and the oxygen are going to go ahead and leave, and the R prime will attach to the oxygen, and so you'll end up with RCO2 R prime plus water. This is called a condensation reaction because it generates water as a product. And so the condensation reaction will take the alcohol and the carboxylic acid and bond them together with a covalent bond from this oxygen to the alcoholic R group. And so these are called, you're going to take your R group that belonged to the alcohol, and you'll call it by its alkyl group name. So maybe it's methyl, for example. If you used methanol to generate your ester, then the first part of the name would be methyl, and then you'll name your carboxylic acid with an O8 ending. So if we used acetic acid or propanoic acid, then this would be methyl propanoate. Methyl propanoate would be the ester formed by the union of propanoic acid and methanol. Esters are really interesting compounds. They often have very pleasant aromas. For example, think like candy, banana flavored Laffy Taffy, for example. The aroma of the banana flavored Laffy Taffy is an ester, and oh shoot, I used to remember the chemical formula for it, and it's slipping my mind. But anyway, it is an ester. A lot of artificial flavorings and aromas are esters. Also, ester formation, you may have noticed, is a way to take two smaller organic molecules and link them together. So we'll see in the next section how we can use condensation reactions, formation of esters, to make very large organic molecules. Ester linkages are useful for that. Okay, so let's do the last one. And that is the amide. Or some people say amide. I go back and forth. I'm sure an organic chemist will have stronger opinions on it than I do. So amides are also formed by a condensation reaction. You'll have a carboxylic acid, so we'll say RCOOH. Only this time, instead of reacting with an alcohol, you react it with an amine. So this would be NHR prime. It could be a primary amine, or it could be a secondary amine, but it cannot be a tertiary amine because it does need to have that hydrogen. Again, the oxygen and the hydrogen and that hydrogen are lost to form water. So one of our products is going to be over here, water, and we'll have RCON. Oops. uppercase N, N R prime. So this is the new bond that is formed that will connect the amine together with the carboxylic acid to make an amide. And the amide is named just like the ester, where we'll first talk about the alkyl name for the amine. So let's suppose this is an ethyl group. And let's say R prime is just another hydrogen, so we used a primary amine. And let's say that this is propanoic acid. So just like for an ester, we will start with the ethyl name, ethyl, and then we'll take the parent name of the carboxylic acid, only this time it's going to end in amide. So ethyl propanamide. In other words, the ending here is just the same as what we call these classes of molecules. They're amides or amides. So ethyl propanamide or propanamide. I'm not terribly confident about exactly where to put stresses and long vowels on some of these names. I'm sure you'll get much better instruction from an organic chemist in your organic chemistry class next year. If you had two different groups on your amine, then you would just list them both in alphabetical order. If there was a ethyl group here and a propyl group here, then it would be ethyl propyl propanamide or propanamide. And again, we've got the formation of a new bond here, and so amides, just like esters, can be used to construct larger and larger molecules. One of the most important instances of that are the formation of proteins and peptides from amino acids. So this is the central linkage between different amino acids to form proteins. So this would be one amino acid, this would be the other amino acid. Every amino acid is going to have an amine on one side and a carboxylic acid on the other side, so that you can chain them together. You know, this amino acid will be linked to the one on its left through its nitrogen, and it will be linked to the amino acid on its right through the carbonyl here. And anyway, so a protein is really just a series of amide bonds, and they make very, very large molecules that perform important functions in our biochemistry. Okay, so let me get back to the figure that we want to see here. Table 21.7 is going to summarize all of the different classes of organic compounds that we have here. It's going to show you what the functional group is and the suffix for the name, and give an actual example. So organic halides, that suffix O is for the substituent, like if it's chlorine, then it would become chloro, and then whatever the parent name for the carbon chain is. So they give you chloromethane. Alcohols just end in OL, so there's ethanol that they show here. Although if you have a longer chain than 2, then you'll also need to indicate the position of the OH group. So There's a difference between 1 propanol and 2 propanol. And then ethers, you're going to take the shorter of the 2 chains and give it an oxy ending, and then just take the parent name for the longer chain. So here we've got methoxymethane, because there's a methyl on either side. If they wanted to make it a little bit more instructive, they would have made them different, like maybe a methoxyethane. And so the ethane is the longer chain, and the methoxy is the shorter chain. For aldehydes, you just end in al, so that's ethanal that they show right there. For ketones, you end in one, so propanone, and like I said, that's got the common name of acetone. And again, you'll want to indicate the position of that carbonyl group for larger molecules. So if you have pentanone, for example, you could have a 2-pentanone or a 3-pentanone. 3-pentanone would put the carbonyl right in the middle. 2-pentanone would put the carbonyl adjacent to the terminal carbon. And the next page here, we've got carboxylic acids. They call that an organic acid. They have the COOH functional group, and they end in the name oic acid. So something like ethanoic acid is acetone. Propanoic acid would have 1 more carbon, or butanoic acid would have another carbon. You never need to indicate the position of the carboxylic acid because it's always on a terminal carbon. For the ester, you're going to use the parent name, the alkyl name for the alcohol. So if you use methanol to form your ester, then methyl will be the name of the substituent group. And then take the parent name for the carboxylic acid and change it to O8. So if you had ethanoic acid based on a parent name of ethane, then it would become ethanoate, methyl ethanoate. For amines, you just name the alkyl groups that are attached and just end with amine. So here we have methylamine. You could also have ethyl methylamine. You could have dimethylamine, depending on which R groups are attached to that nitrogen. And there can be up to 3 R groups attached. That's the difference between a primary, secondary, and tertiary amine. And then finally the amides, which are named just like the which are named just like the esters, except the ending is amide instead of O8. And so you'll take the alkyl name for whatever amine group is used to form the amide. In this case, they show methylamine. And then you take the carboxylic acid name and you end it in amide. So they have ethanoic acid there. We'll change that to ethanamide, so it's methyl ethanamide. Okay, and I know this is like kind of a lot. Like I said, these chapters are really just an introduction to things that you'll cover in much greater depth in the coming years. So chapter 21 will be on our final midterm, and of course it will be covered in the final exam, but only very briefly. I don't think this is quite as important for you to master at this point compared to things like dealing with acid-base chemistry. Okay, so we'll stop there.